So for section 7.5, we're going to look at graphing rational expressions. We're also going to look at isolating for a variable. So let's talk about graphing rationals. So when you graph rationals, you're going to have two asymptotes. Rationals are discontinuous graphs. In other words, a discontinuous graph is a graph that has a break in it or an asymptote. It represents an excluded domain of some sort. So if you look for your vertical asymptote first, it's the domain. So if you can find the domain of your rational expression, which we know how to do, you set the denominator equal to 0, that can be your vertical asymptote. To find your horizontal asymptote is a little more tricky. You've got to look at your degrees of the numerator and denominator. Remember, degree is the highest exponent. So if you look right here in my list, and you're definitely going to want to keep note of this somewhere, don't memorize it. Basically, if the degree of the numerator is less than the degree of the denominator, your horizontal asymptote is the x-axis. If they're equal, it's the ratio of the leading coefficients. That stands for leading coefficient. And if it's greater than, there's actually no horizontal asymptote. Once you determine where your asymptotes are, what you need to do is choose 3 x's to the left and the right of the vertical asymptote and just graph using a t-chart. So let's go ahead and look at this in an example. Alright, for the first problem that we're going to graph, we're going to look at the function f of x such that 1 is over x. So 1 over x is what we're going to be graphing. Now remember, the first thing, if you're following your steps, the first thing we want to look for is the vertical asymptote. And the way that we find the vertical asymptote is we find the domain. And the way that we find the domain is we set the bottom of the fraction, in this case x, equal to 0. So if we set x equal to 0, the vertical asymptote becomes x equals 0. So we go over into our graph. Wherever x equals 0, which in this case happens to be right at the origin where that little red dot is, we put a vertical dashed line. Now be careful, it needs to be dashed because this actually is not part of your graph. In fact, it's a break in the graph. It's a part of the graph that nothing can touch. It's an asymptote. The next thing that we need to do is we need to find our horizontal asymptote. Now when we find our horizontal asymptote, we look at our degrees. So if I go back into the original problem, this is technically an x to the 0. In other words, there is no x, and this is technically x to the 1. So our degrees are 0 over 1, which means the degree of my numerator, which is 0, happens to be less than the degree of my denominator, in this case, which is 1. If we look back at our chart, if the numerator is less than the denominator, our horizontal asymptote happens to be right at the x-axis. So wherever the x-axis is, in this case right here, you actually put a horizontal line through. Once again, dashed. It's not part of our graph, it's a break in our graph. Big difference. Now from here, we're just going to use a t-chart. And what we're going to want to do is we're going to want to choose 3 points to the left of the vertical asymptote and 3 points to the right. So your vertical asymptote is this line right here. I need to choose 3 points on this side and 3 points on this side. 3 points to the left, 3 points to the right. So I'm going to do -3, -2, -1. Those are going to be my 3 points to the left. And then 1, 2, 3 are going to be my 3 points to the right. Now when I plug those in my calculator, what I get for my y's are these. And when I graph those points, what I end up with is a graph that looks something like this. And that would be your graph, or your final solution, if you will. For our last slide on today's notes, I want to take a minute and look at some isolating problems. Let's start with a pretty simple one. I want you to isolate this equation for g. Now you might be wondering, why is this in this section? Well, it's in this section because it's a rational. So remember, if you want to get rid of rationals in anything, equations, in anything, you multiply by the LCD. Well, in this case, this f is technically over a 1, making my LCD d squared. If I multiply the left side by d squared, I better multiply the right side by d squared. And remember, we're multiplying it in the numerator always. What happens is that d squared cancels, giving me gmn equals fd squared. And then from here, to get the g by itself, I can just divide by mn, making my final answer g equals fd squared over mn.